Well, I love how frequent you have become to my page and to my YouTube channel. I say I'm grateful. Thank you for always checking in for the latest solution to questions. Today, we are at it again. Today, we'll be looking forward to WAEC review. We're still on our WAEC review, and we're going to be looking at the question 8, which has to do with a question under the period of a simple pendulum. The period of a simple pendulum. And do not forget that when we talk about period, you cannot talk about period, we're talking about frequency. That is why I'm grateful that you are frequenting this page. The number of times you come here per second is just so amazing. And the doctors, they've actually said it is very healthy for you. Alright, once again, it's Paulamin Physics Online, and we're looking at question 8 of the just concluded WAEC exams, physics, subject physics. And question 8 says a simple pendulum of length 0.8 meters is set oscillating on the planet. If the pendulum completes 20 oscillations in 60 seconds, calculate the acceleration due to gravity on this planet. I always tell my students, no matter how difficult a question is looking, no matter how long a question is, take a time to look at what are those things that you're giving. What are those things that you're giving, and what are they asking you to find from those things you are giving? And the third question will be, what do you really need? What formulas do you need? What quantities do you really need to get first in order to get what you're asked to look for? Those are the basic things. That's exactly what we are going to apply here. Now let's see the solution to this very amazing question. Like I said earlier, this is a question under simple pendulum, basically under simple harmonic motion. Okay, so I'll give you just a little time to just have a peek you into this question before we clean up so that we can solve. So we'll say a simple pendulum of length 0.8 meters is set oscillating on a planet. If the pendulum completes 20 oscillations in 60 seconds, calculate the acceleration due to gravity on this planet and take pi to be 3.14. Right? You just take a little while and think of this question before we start solving. Alright, so let's see the solution to this particular question. I'm going to clean this now. The solution to this particular question. Well, before I resolve, as it is with my usual style, I would likely give a basics, a foundational knowledge of this question we are about to solve. I rightly said that this is a question under simple harmonic motion, and a simple pendulum is one of those examples of bodies or systems that undergo simple harmonic motion. Now, the question says find a period. There are other terminologies that helps us to understand simple harmonic motion. For example, we have cycle, we have phase, we have frequency, amplitude, the period, name it. Alright, this particular question is we're more interested in the period of the simple pendulum. But not to forget, to get period, there is always the need to have an idea of what frequency is all about. Now, what is frequency? Frequency is the number of oscillations, the number of complete to and fro movements that a body undergoing simple harmonic motion does or completes per second. And that is giving us, the frequency is giving us number of oscillations per time. The number of oscillations a body performs at a particular time or per second is giving us the frequency. The period, on the other hand, is the exact opposite, or rather is the reciprocal of what the frequency is, and that is given to us as time over number of oscillations. So how do we define the period of a body undergoing simple harmonic motion? We define it to be the time taken for a body to perform a number of oscillations. The time taken for a body to perform a number of oscillations. So we are going to stick with this formula in this particular question, and we are going to hold it dearly. So please, let's take note of this particular formula. Alright, so let's continue. Now, in this particular case, we are more interested in the simple pendulum, and another case or example is the loaded test tube. But this question is not about the loaded test tube. Alright, so now let's see the formula for the period of a simple pendulum. That will give us T equals 2 pi L over G. This formula can be derived. Maybe in my next video, I will show you how this was obtained, how this formula for period of a simple pendulum was obtained. Well, we are told that the period of a simple pendulum depends on two major factors. Actually, depends on two major factors: the length of the string that makes up the simple pendulum, and the acceleration due to gravity in that particular location that you are carrying out the experiment. Alright, so these are the two major things that the period of a simple pendulum depends on. So we are going to be solving this now for the question once again. Question 8, it says that a simple pendulum of length 0.8 meters. So that's the first parameter that we must take note of. We are given that the length of the simple pendulum, the string that the simple pendulum was made up from, is 0.8 meters. 0.8 meters. And it is set oscillating on a planet, maybe not planet Earth, on a different planet. Full stop. If the pendulum completes 20 oscillations in 60 seconds, 20 oscillations means N. It completed 20 full cycle. It went to and fro 20 times. That will give us 20 what? Oscillations. 20 oscillations. Then the next one says in 60 seconds. These 20 oscillations was carried out in 60 seconds. That is the time T, 60 seconds. 60 seconds. Alright? Now it says calculate the acceleration due to gravity on this planet. Calculate the acceleration due to gravity on this planet. That is, we are going to look for G. We are to look for G. Okay, and we are given pi. We are told to take pi as 3.14. Now, you can see clearly from the formula for the period of a simple pendulum that T is equal to 2 pi the square root of L over G. And we are told to find the acceleration due to gravity. If we observe also, we see that the period is not given directly, but we are given some parameters that can help us obtain the period. If you come back to this formula I wrote here, so that the period is a time taken for a body undergoing simple harmonic motion to carry out a number of oscillations. Now, from the question, we are given the oscillation, the 20 oscillations that was performed in 60 seconds. So from these two information, we can get the period first hand. So the period becomes T equals T small t over L, which will give us that's 60 over 20. 60 over 20, this will amount to a period will be 3 seconds. The period is what? 3 seconds. So we have the T here. We just have G that is not given, and that's what this question wants us to obtain. That's what this question wants us to obtain. Well, let me write this again for the purpose of recalling. 3 as 2 pi L over G. We have to look for G. We have to look for G. Now, to make G the subject of the formula, I will take the square of both sides. That will give me T squared equals 4 pi squared L over G. I'm interested in making G the subject of the formula. G becomes 4 pi squared L over T squared. 4 pi squared L over T squared. G equals 4. I was told to take pi as 3.14. That will be 4 times 3.14 all squared times the length of the simple pendulum, which is 0.8. This will be over the period we got earlier, that is 3 squared. That will be 3 squared. So I'm just going to do a calculation for the ones on top first. So that will give us 31.55. 3 squared is 9, so I'm going to divide this value by 9. 3.31.55 divided by 9. G will equals 3.55 3.50 meters per second squared. This will give us the acceleration due to gravity on that particular planet. And do not forget one of the reasons why this formula is used. It is used to tell or obtain an experimental value for acceleration due to gravity and how it changes from one location to another. As we can see in this particular question, the acceleration due to gravity on this particular planet is 3.5 meters per second. Once again, if this is still not clear for you, I can do a follow-up video. Or better still, give you answers in the comment section. Alright, so once again, question 8 from the just completed physics WAEC exams. Thank you for watching. Do not forget, click on the subscribe button, click on the follow button, and stay connected. Thank you.